All right, well, I guess we'll get started. If you want to wave or something in the chat, I think Ahmed will try to take questions, and maybe we'll save all the questions for the end. Yeah, so I was on Monday. I was kind of disappointed that I didn't get to speak to you in person. I was looking forward to it, for the last month. So I kind of had like, let's try to do something online. So I'm really happy that everybody could join us. Yeah, so let's just get started. So here's a couple, well, a building on the left that I designed. It's a public building in Brockville, and it's got that nice traditional timber frame structure. Most about what I'm going to talk to you today is like, I guess you've been talked to a lot about kind of the mass timber realm and like high-rise mass timber buildings and everything. And so what I'm going to talk to you about is like maybe some of the smaller projects I work on as a small town engineer. And some of it is this kind of resurgence of traditional timber framing, which I think looks super cool, by the way. So I really like those projects. Yeah, so here's what we're going to kind of go through. I'll introduce myself and my company. We're going to talk about modern timber framing. It's a traditional art form that's getting revived. And then we'll talk about some of the kind of projects I worked on and some of the challenges I faced. So I'm trying to like maybe inspire some of you to take a PhD in this kind of stuff and maybe solve my problems for me and update the code in 10 years or something from now. So I'll kind of give you a couple of topics that, these are the big challenges that we're working with when it comes to timber and wood design. Yeah, so my name's Andrew. I finished my bachelor in 2011, did my master's in 2014, and I got my PhD in 2015. While I was doing my master's, I was actually working full-time and doing the master's full-time, so that's kind of how I snuck it in there so quick. I bounced around from a lot of firms, as you can see by that laundry list. So right after school, I was in Ottawa for about 2, maybe 3 years, where I worked at Ron Engineering. So they're like a project management firm. And then I went on to Remich Consulting Engineers, which they're a consulting firm in Ottawa in the Nepean area. After about, a couple years, and then when I finished my master's, I kind of made the conscious decision to move back down to Brockville. I kind of got sick of sitting in traffic, to be honest. I really like biking around Ottawa and all that. So, I would mostly commute by bicycle, but I just found, the traffic was too much. So I moved back down to Brockville where I grew up. I started working for a surveying company. So I worked for them as a summer student, and then like surveying is actually super cool work. It's all about like geometry, history, and law. So it's kind of like a mix of all these things. And so I was kind of thinking like, well, maybe I'll become a surveyor, because this is kind of where I'm gainfully employed in my community, and I enjoyed the work. But at that point, I had 2 degrees in engineering. So I ended up going to the other local engineering firm called Eastern Engineering. I was there for a couple of years, and then I got a job at WSP, which is the biggest engineering firm in Canada. For some reason, they have an office not in Brockville, like in a small town north of Brockville. So I worked for them for about a year on these like giant industrial buildings, a lot of mining and that sort of stuff, mining and oil and gas industry. And I kind of like, if I can design $1 billion mining facility, I'm pretty sure I can go out on my own. And one of the things I really missed was contributing to your community. I think a lot of you'll understand, like as an engineer, the thing you like the most is seeing something you built and contributed to the community. And so that's when I started my own company. Just another little funny thing, I bicycled across Canada in 2014. So I flew to Vancouver and biked all the way to St. John's. It's a super cool way to see the country if you're ever interested. It took about 2.5 months, but that's not what we're here to talk about today. And then in 2018, I was the Young Professional of the Year in Brockville. So that was a neat little accolade as well. So yeah, so like I said, I formed the company. It kind of started as like kind of strictly structural engineering and like trying to focus on community projects. This project here is an old lighthouse that burnt down on the St. Lawrence River. You can see the video online. It's actually quite aggressive fire. And this community started and they wanted to rebuild it. And so I kind of said, hey, like, I can design that for you. I mean, it's 8 posts or 4 posts and 8 beams. Like it's not a hard thing to design. And it's, 15 feet by 15 feet. And then, and they're all happy about that. So, I got to contribute to the community in that way for that project. And then I also managed to convince them to keep it timber framed as well, even though they're all worried about the fire stuff again. And I had to explain to them, hey, but timber is actually pretty good in a fire, so that was quite the conversation. But then after all that, they decided not to protect the light frame structure inside, whatever. So it's going to have a lightning rod though, so it won't burn down again. Yeah, so just recently, actually, just this month, the surveying company I used to work for, I actually just bought. So I bought it with a loan from BDC. So now I've expanded my little tiny structural engineering firm into this engineering firm that now does surveying services as well, and kind of dabbling in architectural design and that sort of stuff. So I'm slowly growing it into this like full service firm where, you know, you don't have to go to 3 different consultants to get a project done. You can just kind of call us up. So, so that's where I'm heading. So where I came up with the name, it's just I figured there's a lot of nice words that start with "in." So and the motto is intelligent, intuitive, inspired. That's it. I don't know. It's really hard to come up with a name. I didn't want to be so vain to like just put my last name on it like everyone else does. So I wanted to be a little bit more creative, and that's kind of where that came from. One of the big goals is I think engineering industry, when you get out of school and into practice, you'll find everyone's still kind of like doing 2D AutoCAD plans, and it's all very archaic, you know, like are they even using viewports, that sort of stuff. And it's because that's the way they've been doing it for 30 years and it's been profitable. But I think there's a huge opportunity for us to start adopting the new technology, including, you know, like the 3D modeling. So everything I design is actually in SketchUp. I've like said, no way AutoCAD. And so that lighthouse there, that's all done in SketchUp, and I'll produce my permit drawings from that. So yeah, so when you get into 3D modeling, it quickly leads into virtual design construction, where you're on site with maybe like augmented reality or virtual reality goggles, and you can see the building as you're designing it. And so this kind of stuff I think is the future of the construction industry, and I'm just trying to stay ahead of that a little bit. And then one of the coolest things is, well, maybe nerdiest things, I think it's cool, but I take those 3D models and then I can render it in like a video game engine. So the company that makes Fortnite, they took their video game engine and gave it to our architects to visualize their projects with. And so I can do that in like, you know, under an hour. So it's a super easy step, and it's got a nice wow factor to it. Yeah, so as I mentioned, the business is located in Brockville. We're right on the St. Lawrence River, which I'm going to give you a little bit of insider trading here. I think Brockville is actually an awesome place to have a professional service firm, because we're an hour from Ottawa, Kingston, and Cornwall. So we're very central to the 3 major cities in Eastern Ontario. And then we're only 4 hours from Toronto as well. So from like a business perspective, I mean, I can reach out to all those markets, whereas someone in the company in Ottawa may not necessarily be able to get to Kingston. So that's kind of the strategy I'm going off of. And then I'm just about finished, but I was in a program called Starter Company Plus. It's a provincial program, provincially funded and everything, and it kind of helps you get organized and put a business plan together and do all the stuff that they don't teach in school. So if starting a business is something you're interested in, definitely look up that program. It was really interesting. It's been going on for about 8 months now, with a lot of follow-up and a lot of support from the community. So is there any questions? Did I miss anything so far? We good, Ahmed? Any questions?
Everything right. Good. Yeah.
Yeah. So moving on to modern timber framing. So, you know, when I was in school, I took like the wood engineering master's course, and I absolutely loved it. And you know, learning about mass timber and all that. And it, like, for me, designing with wood is just, I like it more than designing with concrete. I'm sure some of you will also admit that designing with concrete is a little bit difficult sometimes.
Reinforcements are always a pain, yeah.
Yeah, right. So and then like to draft those reinforcing and make sure you got all the curves and stuff right. Like it's a pain. And so as a consultant, and this is my secret between me and you guys, is I don't really like using concrete. Now I find the wood coat. Oh, and the worst thing about concrete is how all the equations are not consistent units. So I'll show you as part of my workflow, but I use a program called MathCAD. So if you're trying to multiply, you know, the square root of f prime c times anything, it doesn't come out right, and so you have to like mess with it. That's super frustrating for me, because I'm a bit of a computer programming nerd, so I rather program everything. But yeah, the non-consistent units are super painful. Anyway, so I find the wood code it's very well done. It's very modern. They've kept it up to date, and you can tell it's like a new engineering material that they're trying to make relevant. So all the equations are well written out and everything. And so when you're translating that into a MathCAD calculation, it comes out pretty easy. And I like, you know, the aesthetics of wood, this environmental sustainability and all the properties and everything. I think wood is, you know, the material of the future. It was the material of the past, and it's going to come back for sure. Well, and it already has, which I'm sure you've studied a lot about. So here's one kind of an example project.
May
Yeah, go
Andrew,
ahead.
may I just add something? Actually, I was listening to one of the podcasts that is based from the US, and they were saying that part of the reason why the wood industry, maybe one of the things that's hindering it, is the main manufacturers are based in BC in Canada, but I think they're starting a big manufacturing facility, I think, in Texas. So if that happens, then the wood construction industry will probably grow in the US, which eventually will also kind of force the rest of Canada to embrace that change as well. But anyhow, go ahead.
Yeah, so like definitely BC, that's where the big market is in Canada right now. They have all the trees. We're starting to see it come a little bit into Ontario. So they just built a mass timber facility in Collingwood, I think it is. And then there's a couple in Quebec as well because they're close to the forest. And so, like I think Eastern Ontario, Ottawa, Kingston, Cornwall, like that region, we're prime because we're kind of right in the middle of the forest and the manufacturers. So I think so. Part of my goal is every product I get, I was like, hey, do you want to do a mass timber? And most people say no because they don't know how much it's going to cost. But I am advocating for it in the area, and I'm starting to get people interested. So on to traditional timber framing. So I'm pretty lucky. There's a manufacturer in Brockville called Gibson's Timber Frame, and they do traditional timber framing. So everything's like hand cut, mortise and tenon, and everything, and it creates these really nice aesthetics and a lot of this area is still pretty rural, so there's a lot of people with cottages and high-end cottages. It's kind of like, the Muskokas is all sold out, so people are starting to come here from Toronto, and so this is definitely a bit of a premium product, but it's super nice as well. So, every project I get, I like, hey, like instead of doing, your 2x10 rafter or whatever, like why don't we do a traditional timber frame? So the way like the workflow kind of works is the Gibsons, they'll send me a 3D model or a shop drawing, and I'll review and model that in ETABS or SAP 2000. I also have a copy of this S-frame I was playing with a little bit. And so I'll model it. So that's the picture, this picture here on the left. That's, the structural model in ETABS. And then picture on the right is the SketchUp model I get from the timber framers. And so the timber framers, they'll actually 3D model and everything so they can plan out all their cuts and everything beforehand, which really increases their efficiency. So instead of making a mistake and having to throw the whole piece of wood, like they know exactly the parts they need to cut. And then so from ETABS, I'll export the member forces and joint forces, and then I'll use MathCAD. So those of you who don't know MathCAD yet, it's awesome. I'll probably talk about it in a little bit. So I'll use MathCAD to actually design the resistances of the members. ETABS, they don't have a timber module, so you can do like steel and concrete in it, but you can't do wood, unfortunately. So you can kind of do your best to model wood in ETABS, but I just find it too annoying, and I'd rather just import it into my MathCAD sheet. And like all good engineers, I don't just blindly rely on any structural modeling I do. I definitely do some hand calcs as well. So, I'm always doing a couple spot checks here and there, making sure it makes sense. And then if it's something simple like a post and beam, I'll just hand calc it and I simply support it or something like that. And by hand calculation, I mean I'm just typing it in MathCAD. So here's a MathCAD. So maybe, well, I can't really do a show of hands or anything, but is everybody familiar with MathCAD? I guess your professor kind of used it a little bit, I think. Anyway, so my favorite thing about MathCAD is you can multiply like inches times centimeters and meters times feet, and like it doesn't care, right? Like the units stay consistent. So you'll see my sheets all the time. It's switching back and forth from units. Like I don't even know conversion factors anymore, and like if a contractor gives me drawings in inches and I'd rather work in metric, it doesn't bother me. So I found a huge efficiency just not having to go back and forth with units, which you could probably imagine from an exam. Like that's definitely time consuming. Also, you can copy and paste all your previous equations. So this is kind of a snippet of one. I have like a timber framing MathCAD sheet that every new project I get, I just pretty much copy and paste that sheet, which allows it to me to just not have to retype out everything. So you probably recognize some of those equations. Anyways, and it's also, there's a free version as well. So if you haven't tried it, I definitely highly suggest you do try it, especially when you get into the workforce and you need to make, calculation briefs or something like that to get to your boss. This just keeps it all organized. They don't have to read your bad handwriting. If there's a mistake, you don't have to rewrite everything out. You can just go back to the sheet and fix it. So when I first got into this, I think it was because I rather work in metric because that's kind of what you're taught in school. But my boss was like all imperial, and so I was just like, it was just super frustrating going back and forth with him, and like because he didn't know what an MPA was and I didn't know what a PSI was. So so I found this and I was like, yeah, like of course there's a better way to do it. And that's kind of how I came across MathCAD. So it's a great tool to use, and it produces great hand calcs as well. I wouldn't suggest getting into it if you're still in school, because like I said, I don't remember any of the conversion factors anymore. And if you're in the middle of an exam, you kind of need to remember those to do it fast. And I can't remember how to use my calculator anymore. So just be wary of that. It's definitely a post-school thing, I think. Yeah, so some of the interesting things, I know like in school, you don't really get into building code stuff too much. But the great thing as a structural engineer to get into timber framing is it has to be engineered. So in the building code, there's Part 9 small buildings and then everything else. So small buildings are like houses and buildings under 600 square meters, less than 3 stories. And these can be designed by a BCIN, so a building code identification number person, like an architectural designer. Now they're super limited in what they can do. So, they can only do 8-inch concrete foundation walls on 24-inch strip footings, and they can't have openings greater than 4 feet, this kind of stuff. So what happens is if they have anything outside of their prescriptive requirements of Part 9, then they have to get an engineer involved. And so the nice thing about like a traditional timber framing, it's all post and beam style construction. So there's no, light frame shear walls or anything like that. So anything with the post and beam style, it's not in Part 9. So then it has to be designed by an engineer. So if this is something that interests you, it's a great industry to get into, and not a lot of engineers do it. I get a lot of clients saying, like, I wouldn't call myself an expert in wood, but I get a lot of clients saying like, oh, like, I guess like I was working with my regular engineer and they don't know enough about wood to be able to design, a truss, for example. And I'll tell them, well, like, yeah, I do that all the time. And so that's great. So I actually end up getting a lot of clients from other engineers because they're just not confident in wood, even though it's such an awesome, simple material. Yeah, so some other Part 9 restrictions, the lateral force resisting system is light framed walls, so you don't really have to design for wind and earthquake, but sometimes you do. So a project like the one on the screen there, it's big enough, I'll design it as a lateral force resisting system. But most of the time, like if you're just doing like a front porch or something like that, like the smaller ones, and you don't really have to do wind and seismic, it's just gravity loads, but you still have to kind of consider it, make sure it's okay. But normally the house itself that's designed to Part 9 will resist the lateral loads. So here's a good example project. Is also the one at the start of the presentation. So this is in Brockville. It's a community building, so it has like a Zamboni garage, 2 change rooms, and a little canteen. And it's beside an outdoor rink that they just put a roof over. And so I got involved with the project. They asked me to kind of volunteer for it. I was like, okay, but if I volunteer for it, it's gonna have some kind of timber framing element. So that's what you see there, and it really is a beautiful building. If you're ever in downtown Brockville, then stop by and take a look at it. It's made from Eastern pine, which is not part of SPF. It's a northern species, so I'll get to that in a little bit. But most of the wood that you can get locally in Ontario is all northern species, which, if you remember, is kind of the worst type of wood you can use. But in this case, the structure worked out. The big thing is the tension load on the bottom chord of the truss, or a bent, a timber frame. It's called a bent, B-E-N-T. There's a lot of tension that's transferred through here, and so there's actually hidden knife plates right in here, across the middle, and right here, just to keep those tension forces. So the one bad thing about using natural lumber is it's not very good in tension, because you get the shear knockout at the bolts and everything, at the bolts and pegs. So we have hidden knife plates in there with hidden bolts, and those are actually faux pegs, but it keeps that elegance of the wood look and everything. And then we have a steel plate at the bottom of the post to the concrete foundation, and that's just because like you don't want wood to ever touch concrete. Did you guys ever kind of touch on that at all, Ahmed?
Yeah, in the beginning of the course, it's because of the humidity transfer and shrinkage that may occur in the wood because of the direct contact with concrete and masonry. Yeah, I think I touched on it in the beginning of the course a little bit, yes.
Yeah, so normally, like anytime you have a wood post on a concrete foundation, there's some kind of steel element there to separate the two, because the wood will suck up the moisture from the concrete and end up just rotting quicker. And you also want the post a little bit off the ground, so the post isn't sucking up water as if it's sitting in a puddle or something like that. So historic timber buildings, there's a lot of these around. A lot of engineers don't like touching them for obvious reasons, and there's a lot of challenges to them as well from a structural engineering perspective. So this is a building in Brockville. You can see there's someone signed it in 1891, I think, or 1814 even. So it's one of the older buildings in Brockville that's under renovation right now. And so I'm going through it with them, and they got big plans. And one of the worst parts about being an engineer is crushing people's dreams. Like architects can be lofty and visionaries, but then the practicality of it is you go in there and be like, well, if you do that, it's going to cost a lot of money. So, but anyways, so that's some nice old wood framing there. So to use CSA 086 engineering design in wood, you have to use graded lumber and with the correct species. I'm sure you went over that. And there's so all structural lumber has to be graded, and except for a small portion of buildings that can be classified as farm buildings. But I even think they're kicking that out of the code because it's just like the National Farm Building Code isn't very good. So they're either updating it or just putting it under Part 9. And so when the timber framers get their wood, they have to source it from a supplier that can get it grade stamped, right? So you're not going to see the grade stamp like here on the picture. They'll get a certificate of grading. So when the timber framers get the lumber, they get the certificate that it's been graded. So, it's spruce, pine, fir, northern species, blah, blah, blah. And then they should give a copy of that to the client so they can prove it. When you're working for municipal clients or townships or bigger clients, they're going to want that for the records, obviously, because, a lot of timber framers, they could just go out and source it from a farm or something. And if it's not graded, then theoretically it has no structural value to us. And that's because 086 relies on graded lumber, which goes into historic lumber. So the National Lumber Grading Association didn't create their standards until about the 80s. So any building before the 80s is probably ungraded lumber. And this is where the big problem comes in. So if you go into a building and they want to increase loads or move walls around or remove a floor, and it's all ungraded lumber, then theoretically, they have to abandon all that lumber in place and do a brand new structural system. Because the code says, if you're leaving it as is, it's fine. But the second you start upgrading it too much, then we're going to implement the new standards of the code. And so you might have heard that as like the grandfather clause and that sort of stuff. But it's a huge challenge because you go into these beautiful buildings and the client's got this great idea for it, and you're like, well, we really can't touch anything, or it's going to start this like cascading of ungraded lumber failure all throughout, right? Like you can imagine if you move one joist over, then it's going to affect the joist beside it, right? So then the tributary width of that joist is now longer, and so then it just keeps going on, and then the posts now have an increased load, so then the post can't be considered anymore. So it gets messy really fast. So just be wary when you go into an old timber building. There's a reason that sadly that a lot of them are getting torn down. It's because it's ungraded lumber, and the renovation costs are just too high to get it to code. And so yeah, I put it in here like just as a note. Eastern pine is not SPF. It's not under the spruce pine fir category. It's under the northern species. And so a lot of these traditional buildings are probably made from northern species. The Grand Trunk Railway opened in the 1860s. So buildings prior to 1860s, I generally assume they're northern species. And then sometimes you can maybe get Douglas fir after that. So for bigger buildings, but here's just some of the considerations to take. On the Canadian Wood Council website, they have a great species chart of where all the lumber fits in. Did you guys go over that at all offhand?
No.
Yeah, so I put a link at the bottom there. It's a great chart. I reference it all the time when people are asking me about weird species of wood, and it just shows you like where the species comes from, like what's categorized under that, and its geography. So I put the example there for Eastern pine, which is included in northern species. So just don't make that mistake, because there's quite a huge difference in strength values from northern species to SPF. So renovating historic lumber buildings. Yeah, so like as I kind of mentioned, we can grandfather it. It's it's Part 11 of the building code, as long as you're not reducing the performance level. And there's a bunch of criteria on what happens when you reduce the performance level. So like I said, increase loads or switch things around too much. So yeah, so when you go in an old building, like most of the time you really can't do anything, or you're redoing everything. Unfortunately, like there's no lumber graders that will do a site visit for you to grade that lumber so you can keep it in place, which I think is really difficult. And I've even, as a structural engineer, I started looking around to see if I could find a way to get my lumber grading certificate so I could go on site, certify the lumber, and then design with it. But there's no field certification course. They're just focused on the manufacturing facilities, which is kind of bizarre. So I think there's an opportunity there somewhere for somebody. Yeah, so if you do reduce the performance level in a historic timber building, then that means you're just kind of abandoning in place and doing a brand new floor system, for example. And then the funny thing is the National Building Code. So if you're on a federal building, for example, it doesn't have any grandfather clauses. So theoretically, if you're renovating an old building, this is my understanding, I'm probably wrong, but if you're renovating an old building, then you can't reuse anything, which I find really bizarre. So I'll probably looking at more, but I mostly deal in the Ontario Building Code. Yeah, so here's some future opportunities for some of you that want to maybe study this further or come up with something. So yeah, as I mentioned, a field certification course for lumber graders. I think, I had the thought at one point, like we should start like a structural engineering lumber grading association, or something like that, so we can deal with this issue on site. Like there's no reason why we can't go in there and grade the lumber visually. It's just that doesn't exist at this point in time. And so the same thing is like, it'd be nice if the CSA 086, it provided provisions for ungraded lumber, like what if we just made it more conservative or something like that? Like all these old lumber buildings are so over designed anyways, and they're all true dimensional lumber. Like, the joists aren't 1.5 inches by 7.5 inches, they're 3 inches by 8 inches, so I think there could be future studies done, on a way to do that safely. And it'd be nice if 086 enabled engineers to complete that. And then, we can start saving more of these old buildings versus having to tear them down because the renovation costs are too high. Yeah, so 086 is also focused exclusively on softwood. It'd be neat if we could start getting some hardwood species in there and maybe a system to grade that. You'll never see like a hardwood structural timber frame, for example, and it'd be really neat if we could. I know that the American system, I think they have published values for hardwood species, but it's just not an acceptable solution in Canada yet. And then there's a whole slew of things when it comes to wood design. So I think the steel code has done really well in identifying like seismic force resisting systems and, and partial fixivity and, these kind of higher level ways to analyze. And so I think there's a huge opportunity in timber or wood and engineered wood and timber framing to do like partial fixivity, for example, of a timber frame connection. It is kind of like an old traditional way of construction. And so bringing it to modern standards would definitely enable engineers to come up with better solutions. You'll see there's a question here. Is hardwood not more at risk for brittle failure? Yeah, exactly. So like that's why you will never see it used, but you can always limit the brittle failure with your connections and that sort of thing, or design for it. I don't know, Ahmed, do you have anything to mention on that? You probably know more. I haven't done a lot of hardwood stuff before, so.
No, I never done any either. So I'm not sure.
Yeah, like I haven't, like, unfortunately Canadian engineers aren't enabled to use hardwood. So that, maybe that's something, maybe you got a master's thesis out of this presentation. So that's what you go on to do. So unfortunately, I don't know. It's just because as a consulting engineer, we don't get to use hardwood, and I would love to use hardwood. I think it makes some really, really neat designs. All right, so we did get a whole slew of questions, so I'll try to bash through these. If you want to ask some more questions in the chat, I do get a little notification, so I'll answer it right away. So someone mentioned that they're passing by a site and the wood was exposed to snow and rain. Is that normal, and will this affect the strength of the wood? Yeah, so one of the biggest downfalls is when wood gets exposed to rain and water for a long period of time. Wood's actually really good at drying itself out, and as long as you maintain that, I think it's 15 to 24% moisture content. Is that right?
Yes.
Yeah.
Under 19%.
Yeah. So as long as you maintain that moisture content, mold won't grow and that sort of stuff, and rot won't form. So wood can get wet, and just as long as you allow it to dry out. So what happens in, let's say, an old house is you have sheeting on one side, drywall on the other side, and moisture gets into the wall, and it's sitting at the bottom of the wall for a long period of time. So that wood's going to start to rot. And so on a construction site, they do try to protect CLT panels and that sort of stuff from rain, but it can get wet as long as before they seal the building up, they allow it to dry out. So, they might put the building envelope on and then run fans on the inside or something like that. A lot of times you might see, like vapor barrier, like a peel and stick product on top of the CLT panels just to keep them out of puddles and that sort of thing if they're going to be exposed to moisture for a long time. Yeah, so structures that use a combination of steel and wood, well, I put a picture right there for you. So there's a lot of neat designs where, there's a steel frame and then a CLT panel, cross-laminated timber panel. I really like that design. Like, I think that looks really sharp, especially when they do like the carbon black steel. I think that looks really neat. One of the problems with exposed steel, it has a terrible fire rating. So, the steel is going to fail before the wood. So, then you're getting into extra costs for protecting the steel with, intumescent paint or something like that. Whereas if you did a timber structure, the wood self-insulates itself from the fire. And so to get like the 45-minute or 3-hour fire rating you need out of the structure, wood can achieve that by itself and be exposed. And then, so a lot of times, I kind of mentioned earlier, like, if I have a high tension area, then I'll use a steel connector, hidden knife plate or something like that in the timber frame. So there was always kind of some kind of steel aspect to wood construction, just because you don't want it to touch the concrete. What is the most interesting wood structure project I worked on? So I talked about it a little bit earlier. The P&G Pavilion was definitely a really neat project. Here's some of my drawings that are made from my 3D modeling. It's always nice to contribute back to the community, have a budget that you can do something really aesthetically pleasing and that everybody's going to enjoy. So so I definitely really enjoyed that project, and it had its challenges, and but the best part about being an engineer is overcoming challenges.
Just Andrew, because
Yeah.
you just talked about the pavilion, there was a question just now about if you had any measures put in place to deal with salt at the feet of the column in the pavilion project.
Yeah, so the at the feet of the column, the posts are about 2 inches off the ground, so there's a steel plate in there, and so it's kind of like a steel T plate, and then there's another plate underneath, and so that raises the whole post up a few inches. And that way, if there's any water or anything like that, it won't affect the wood. And then the steel plates, it's painted, so it's protected from rust. Did that answer your question?
I think so. Yeah.
Okay. So, what do you think the trends will be for the next 5 to 10 years? I think the industry is definitely going to go into this pre-manufactured route where all winter long Canadian companies, they can produce all the materials and then they erect buildings in a couple months in the summertime, just because, we do have a limited construction season, and any way we can alleviate that, you're increasing the amount of construction you can do. And therefore, if you're a manufacturer or a builder, then you're going to produce more money. So as things head more into pre-manufacturing, then, that's a great opportunity for wood because they've adopted that pre-manufacturing model. So, for example, steel manufacturers, they will pre-manufacture the whole building, then you just erect it on site, a few months later. And so wood's doing that as well. And I definitely think that's the way it's going to go, especially like, modular design and pre-manufacturing, just to speed up construction time. So I'm sure you studied it, but the Brock Commons building in BC, the first or tallest mass timber building for a little while, it was built in something like 30 days, and it's 30 stories. Like, I don't quote me on those numbers. You'll have to look it up, but it was built really fast. And, I think that's a great opportunity for the construction industry. So if you're newly graduated and you want to work in the wood industry, I would, if you're open to moving, I think BC is probably the best place for you to go to find companies, because this is widely adopted in BC and Seattle and that kind of, and the West Coast. There are a few local suppliers in Ontario, Quebec, and so those are the few of them there: Element 5, Guardian Structures, and Nordic Structures. So if you wanted a job in the industry, what you would do is you would apply to these companies and be part of the pre-engineering team that would actually engineer the structure to ship to site. So me as an independent consultant, if I want to do a mass timber building, what I would do is I would talk to the client, kind of lay everything out, maybe design the foundations, and then say, we're going to do a pre-engineered building. I don't really design any of it. I might rough in a couple of things to make sure there's no no conflicts, but I pretty much send that building layout to one of these companies, and they engineer, design, fabricate, supply, and install everything. So if that's what you want to end up doing, then that's definitely where you should go, is target some of these companies. So there's a bunch of them out there, all different sizes. So it's really what you want to do. The sad thing about being a consulting engineer is, I don't get my hands on this stuff as much as I would like because it comes pre-engineered. So tall wood structures have been making the news lately. And the building code's getting modified. That's right. Where's the limit? So I'm a small town engineer. I usually go up to 3 stories, if that. So I don't get a lot of experience working with tall wood structures. Obviously, someday I would love to design a tall wood building. But just from what I know about wood, I kind of mentioned the tension connections are really difficult with wood. So, if you're doing a tall wood building and you have, your seismic resisting system is a braced frame, for example, and you're relying on tension connections for your seismic resistance, you're going to have an issue there, I think. So, obviously, the taller the building gets, the beefier the connections need to get. So that's really going to be the challenge. Engineered wood products help with that by, cross-laminating or glue lam, that sort of stuff. They definitely help with that tension problem, but you won't see natural lumber in a tall wood building, that's for sure. But I think the economics are there, the buildings are lighter, and if the building's lighter, you can go taller easier, that sort of thing. So it's really interesting seeing some of these proposals that are out there for tall wood buildings, and like I said, the limit's probably in the tension, but I don't deal with it enough to know how high we can go with it for sure.
This is the one in Tokyo, no?
Yeah. Did you want to touch on that at all?
No. I just saw it as well when I was preparing for one of my lectures. I think this one was in Tokyo. I think they wanted to go 80 stories or something. I don't remember, but this is still in the planning phase. And actually, about the connection resistance, in a few of the examples, I remember there was an example where you have the capacity, even if the capacity of the glulam member is fine, transferring that load it might be a big challenge because of the way timber connections are.
Yeah. You're like block shear tear out, right? That's the big limiting factor of wood, really. If you have these high tensile connections, it gets really difficult. Even like a timber frame, 20, 25 feet, we're getting a little iffy. So it's and to design a steel plate that will transfer that load, it's pretty difficult. So we're limited even with a structural timber frame how wide we can go.
Yeah.
But where we're limited is a good opportunity for someone to maybe do some studying and solve this problem for us.
Exactly.
How often do I reference the design manuals? So they live on my desk permanently, and I look at them every day. So here you can see my desk. Got the building codes here, and back there is all the design codes, national building code. Yeah, so I mean, I'm looking at them every day. There's no way you can memorize it. So pretty much any project, if I'm doing a wood product, like the CSA 0886 code is right beside me. With MathCAD, I've kind of programmed a lot of the code in the MathCAD sheet, so I don't really have to reference the code too much, but there's always something to look up. So all the time. So if you have a copy of the code, it's a good thing to have as you get into the workforce. How much did your coursework help in your professional career? I think the biggest benefit to my career was while I was studying masters, I was also working in a consulting environment. And so, I could kind of apply what I learned to masters to school and vice versa, or to work and vice versa. And I just, I think it helped me understand engineering better. And between you and I don't think I really knew how to engineer until I did my master's. So it's a good thing I did that program. So I think it's a good idea. The MEng program, it's 10 courses. And if you can kind of get a little bit of work experience and then do the MEng and have an appreciation for what you need to learn, then it's a great combination. And then when you get to the workforce, like a lot of EITs, they'll start out in drafting, that kind of thing. And unfortunately, you don't get a lot of experience on proper drafting standards and that sort of thing using AutoCAD. So it's a little bit of a painful experience. You're like, I know how to design a beam, but I don't know how to draw one, right? So that's definitely, if you can brush up on your skill, like if you're looking for a skill that you're going to use, drafting and that sort of thing, it's definitely a requirement. And but most employers, they'll let you learn or whatever. I think we got a question here. For steel, their fabricator catalogs, are there similar ones for wood, or do you just use a code? Yeah, so a lot of the manufacturers, I think they've kind of grouped together and they started making their own design codes. So there's like a CLT design manual. Have you come across that, Ahmed?
Yes. Yes.
Yeah,
There's
so
actually a new version that just came out, I think, 3 or 4 weeks ago.
Yeah, so there are resources out there, like if you want to find like a good connection, that sort of thing. But I also find the wood code it's really informative. So I don't have any catalogs necessarily that I reference all the time. The big one is just LVL properties. I think I have that one permanently saved. But yeah, so that's a good idea. Maybe I should start looking at it and get some good connection details. That's not a bad idea. So yeah, so every time you take a design course, this definitely helps a lot with learning the codes. And anytime you can do self-study, but like you're not going to read a design code at home by yourself. You kind of need a product to go through just to learn it. So I think that repetition of doing a beam design and looking it up in the code or whatever table you need to know is the best way to go.
We have another question. So someone's asking, when assessing historic timber, how deep can checking become before you would consider it as cracking or before it's problematic?
Like checking is a normal thing in wood. So it's, yeah, like I would probably look more, if I was looking for like failure of the joist or something, I'd look more in like the deflection of the floor or something like that. And if a joist is cracked, for example, and the floor is not deflecting, then it's fine, kind of thing. And the Ontario Building Code kind of allows for that. So, like unless I was cutting a joist out and putting in a stairwell or something, then I might replace it or sister it up or something like that. But the big indicator for failure is deflection, I think. And so, or if there's actually like a tensile crack in there, but checking itself, it's pretty normal in wood. And the correct me if I'm wrong, Ahmed, but the wood code, like those reduction factors are for checking, for example.
Yeah.
Yeah. Answer your question?
Yep.
All right. So done those questions. Market for mass timber in Canada. Yeah, so there's definitely a huge market in British Columbia, like I mentioned. Ontario is growing and starting to adopt it. If I had my way, like Eastern Ontario will have the next mass timber building if I can get a client to take the plunge. I would love to start seeing it, in like Ottawa and that sort of thing. There's a few going in Toronto. Google Sidewalk Labs, which is this huge development in Toronto. I don't know if you've been tracking that one. It's actually supposed to be all mass timber, which is an interesting idea. So that will be this huge complex in the middle of Toronto that's going to be mass timber. Yeah, and then as far as like light frame wood, like everyone's house is built from light frame. A lot of commercial buildings are, so there's always going to be a market for that. In other countries, I know like Scandinavian countries, any country that has a big wood industry is all about this product. So a lot of these CLT panels actually started in Austria and Switzerland and that sort of thing. So I think Europe is definitely adopting it. And if you get into the mass timber market, with the the Canada European Trade Agreement, is that the one? CETA? Anyway, so we have a free trade agreement with the EU now, and obviously mass timber is part of that. So there is a big as Europe starts adopting it, there's a big opportunity for Canadians there.
I think did you skip a slide by mistake?
Yeah. Growing market.
Oh, okay. No, never mind.
Yeah.
Yeah.
I just rolled my mouse too hard. So high-rise buildings without a concrete core. Yeah, so back to, I'm a small town engineer, so I do mostly small buildings. I know a lot of them, they do have the concrete core for their lateral force system, and it's probably because you can't do a concentrically braced frame with the tensile resistance of wood and the connections. So I think a lot of it for the shear resistance, you're going to see those concrete cores, or some kind of hybrid like steel braces with wood posts or something like that. Yeah, and then that's obviously something to research. And like I kind of mentioned before, the steel code does the provisions for seismic force and lateral force resisting systems really well, and it'd be neat to see the wood code start adopting that. Like, how do we do a full mass timber building without having that concrete core? And the other thing is CLT panels can be used as shear walls as well. So if you're not going to have that concrete core, then you'll probably see CLT panels on the walls. But then that also means you don't get those like nice floor to ceiling windows that people like, or all glass buildings. So that's why you'll probably see more of the concrete core with wood posts and beams.
I can also add on that, because I am a bit familiar with some of the research that's being done. So the CLT shear walls, definitely there's a lot of research worldwide that is focusing on that. I know a big research focus in New Zealand is working on that as well. Something that has been done at Carleton under the supervision of Professor Irochko was a couple of more colleagues who were working on creating moment-resisting frames for wood. So what they would do is the connections themselves would be steel plates, and they would be connected to glulam members using glued-in rods, right? So they would drill the holes in the glulam member, and they would basically inject the holes with epoxy, and they would fit the rods into these holes, and that basically provides the connection from glulam to the steel connection, and the steel connection basically connects all the different glulam members. So that way you can actually have a lateral force resisting system that doesn't involve a concrete core. Another thing is also maybe using friction braces or friction dampers and BRBs. Now that you have that connection made out of steel, you can actually use regular BRBs, or BRBs, by the way, is buckling restraint braces. That's an advanced system. But I'm just saying there is different ways now that that you can connect wood members that would involve steel. Now the aesthetics, I don't know. I don't know how aesthetic it could be, but that is definitely one of the research topics that are being considered.
Awesome. Yeah, so there's another question here from Rebecca about fire safety and how can timber solve that problem. So it's going to sound super counterintuitive, and I have this conversation a lot, but mass timber buildings actually perform really well in fire. So wood burns at a predictable rate, which makes it really easy to engineer. So wood burns at about an inch an hour, I think it is. And so if you need a 3-hour fire resistance on your building, you just add an extra 3 hours of wood, or 3 inches of wood. And so the concrete core, like, it might protect the stairwells, for example, but the wood structure itself is actually very good in a fire. And one of the big problems is with mass timber, it gets compared to high-rise light frame buildings, for example, which those are the stick frame, and those are the buildings that go up in fire really quickly. It's kind of like when you start a fire, you put all the kindling on first. You don't just throw a giant log on and try to light that on fire. And so that's kind of the analogy. Hopefully that answered your question. It's if you're interested in that topic, I know Carleton has some great fire resistance engineering courses. I took them all. They're super cool. And you can kind of learn about that a little bit more. Is that good, Rebecca? Awesome. All right. So any issues applying to my license? Yeah, but the biggest issue with applying for my license was I had to mail my application in, and like I couldn't even fax it in, right? Like I had to handwrite it out and mail it in. And so I think they're working on that now. Like I don't think it's quite finished yet, but I've just found it really weird that, the professional engineers of Ontario, like, we're supposed to be like the leading edge of technology. You had to snail mail your application in. Anyways, but no, for my license, as long as you're trained in Ontario at an accredited school, and you get the right experience, it's a pretty good process. I would recommend writing the professional practice exam as soon as you get out of school, because a year later after school, you forget how to be a student and how to study and all that stuff. So if you write it right away, then you can forget how to study and be a student and get into the workforce. And so like the big thing is getting the right experience. So my first job at a university was at a construction project management company, and they'll only accept like 6 months of that, or like maybe up to a year of that. And you can't get your PNG if you're only doing project management. So if that's your goal, then definitely do a little bit of project management to start, but make sure whatever you're doing is acceptable experience. How did I find the professional practice exam? So I had this whole binder of past exams that other people that I worked for kind of passed down to me. And I studied those, and it's a 3-hour exam, and I wrote in an hour and a half. I didn't find it that challenging at all. It's a lot of like legal stuff, but as an engineer, I think we're really good at finding the patterns. And once you find the pattern, it's pretty easy to write. If any of you are interested in my professional practice exam bundle, I can send it to you on Google Drive. I still have it all saved somewhere, so it's pretty handy stuff. Yeah, so if you want that stuff, just my email's at the end of the slideshow. Just send me a quick email and I'll share the link with you. Major problem that you encountered in the industry, and how did I solve this problem? Yeah, so like I've had a great time being an engineer in Ontario. Like, I've learned more as a sole proprietor, like what are the limitations of engineering. So it's so now I'm starting to expand my firm to fill in those gaps. And like a lot of it, as long as you have good base knowledge and just apply that good engineering judgment, then I think you'll all do really well. Obviously constantly reading, constantly studying, like keep up on the craft. You're gonna be reading the building code every day, and eventually, after a couple of years, you're gonna be an expert in it. And like Grandma Google's great for finding help and examples or ideas. Like a lot of times, if I need a connection example, I'll just Google, hey, timber connections, like let's find some inspiration here. Yeah, so that's definitely it's a good question, but I think it's a great career to be in. Like even during the recession, never had a problem finding work or anything like that. Even right now in the pandemic we're in, like I'm very confident that my business will do well. And yeah, that's anything else on that? I don't think so. All right, you have anything else on that? I don't know what else to say about that. How did I start my own consulting business? Well, so I always knew I wanted to start my own business. I guess some people just have that entrepreneurial blood or something, but even in university, like I was like, like I know I want to start my own business. I don't know if it's in engineering or what, but I know I want to run my own business. And so I remember like way back when I was at a PEO event, and I think I was still in EIT, like maybe when you're graduated. And I sat down beside this engineer, and he just started his own consulting firm. So I was like, oh, this is awesome. This is a good opportunity to figure out how to do it. And so I asked him, I was like, oh, like, what do you do? And he said, oh, I just started my own consulting firm. And I was like, oh, that's great. Like, that's a goal I have in mind. So how do I go about doing that? And he gave me this like terrible answer. It was like, oh, like you'll never do it. Like you got to work for 20 years and then, like have 6 years of salary saved up, and then maybe you can start your own firm. And I was like, oh, like that's kind of depressing. Like it's going to be 20 years before I can achieve this goal. So terrible advice, right? And so I've always had this goal in my mind, but it really came down to when I felt confident enough to go out on my own. Really, I have a good technical background that enabled me to like set up a good website really quick, and I have a like Brockville is a small community, but it's a small community, so I had a lot of good connections to start with. So I knew a lot of people in the industry already in the area, so it just seemed like a logical transition. And I was working at WSP at the time, and it was great working on these big corporate projects. But like I said, I just wanted to work on my community. I wanted to improve my community, and so that was the big decision making. So while I was at WSP, I was actually moonlighting. And so I was like working on these big industrial projects in Northern Ontario while moonlighting small engineering projects in my town. And like these projects would be like designing a beam so you can have an open concept kitchen. Like they're not that crazy. But long story short, WSP didn't really like that I was moonlighting, even though it's allowed in the PEO code of ethics and it was allowed in my employment contract. I had to make a decision. And so it was a pretty easy decision to make to go out on my own. yeah, I had to go off the deep end and start running my own business. But like I said, I had a lot of support from the community. So I went into that starter company program, which, helped me get a business plan together and put me in a bunch of contact with, like-minded people. And, so the benefit of being in a small town is, like everyone's out there to help everybody, I think. And, it's a great place to start a business for sure. The biggest challenge, it's just, like I said, it's all about getting the confidence. Like eventually you're going to get to a point in your career where, you feel like you can design anything, and that's a great point to be in. And if running your own business is something that you want to do, like, don't take the advice this other guy gave me. I would say just go for it. It's a great industry to be in, and as long as you have a plan, like getting a business plan is super important. Then go for it. One of the greatest things about running your own business is, like in the morning, I'm doing engineering calculations. In the afternoon, I'm doing drafting, and sometimes I'm doing marketing or, business development. So like, you're always doing something different every hour, which is kind of nice. I think, especially for the millennial generation that, we have short attention spans maybe. So prior to starting the business, so I worked as a project manager, a surveyor, a structural engineer. I think all these were a good mix to see like how the construction industry works from start to finish, and make sure that my business is serving the community. Okay, so that's the end of the official questions. There's my contact information. So if you have anything else, feel free to send me an email. More than happy to mentor you as you start your careers or give advice. I think, one of the most important things about being a professional is also mentoring people as well. And, I kind of have the nice benefit that I'm like 5 years ahead of you. So it's good that I kind of have this fresh in my mind. But even though I had to mail in my application, like maybe I can help you out, fill it out digitally in the future. And then, so I am growing my firm. I'm not hiring exactly at this moment, but if you want to send me your resume, feel free to, and I'll kind of keep it on file for when I need to find someone. I'm really looking for someone that wants to move to the Rockville area. So if the small town interests you, then that's really important. One of the biggest challenges is finding people in small towns, all the talents in the city. Also, if you want to connect with me on LinkedIn, it's a good way to stay connected with what's going on with the business and what I'm up to. And, I'd also invite you all to, y'all, did I just say y'all? From a small town, right? So I also invite everybody to like me on LinkedIn, Facebook, and Instagram. That way you can just stay in touch and see what I'm up to. And if anything's interesting, I can always answer questions. Were there any other questions?
I can actually add a question here because I remember you mentioned this during the presentation. So let's say you have a large building, so it's not like a residential building. Let's say like a warehouse or something, and it's not a federal building. Do you still use the National Building Code, or would you use the Ontario Building Code?
Yeah, so if the building's in Ontario, we would use the Ontario Building Code. If it's on federal property, it's probably the National Building Code. I've ran into a couple projects, like the duty free, for example, on the border. It's actually on federal property, so theoretically it's to the National Building Code, even though it's like a private business. But then again, they want to submit a building permit out of respect to the local township, and they're going to want to see it to Ontario Building Code. So it does get messy. But yeah, like federal buildings, like anything on federal property is National Building Code, but otherwise it's mostly Ontario Building Code. The reserves, they're kind of unique. Some of them have adopted the National Building Code, some of them adopted the Ontario Building Code, and some have their own. So you really got to check with the local people there.
Well, I mean, is it different? Because at least at Carleton, we teach the National Building Code. Mm-hmm. So will it be a problem for students graduating? Especially now, I think some of them may have some extra time, so maybe they can have a look at the Ontario Building Code. Is it that different that they can't figure out the differences on their own?
Yeah, so the Ontario Building Code is still, like all the provincial building codes are based off of the federal National Building Code.
Okay.
Ontario is still based off of the 2010 National Building Code. And so there are actually some pretty big differences when you look at it. Like they've arranged equations and that sort of stuff, and there's some differences. Like all the seismic values have changed, for example. Yeah, so the Ontario Building Code is quite a bit different. And then there's also like a whole bunch of different parts as well. So there's like part 10 for change of use, part 11 for renovation. You have all that like SB1 for climatic data, and then there's like SB10 for farm buildings and that sort of stuff. So I would definitely, you are going to work, whatever province you're going to work in, definitely start going through the building code and kind of comparing and contrasting the differences so you can talk the talk. It's not super staggering. Like it's, if someone hands you the Ontario Building Code, I think you'll be able to understand it with your National Building Code knowledge. But then again, there are like, for example, we don't study Part 11 renovations in university, and I've had to learn that stuff myself, and it's something I use every day. So definitely, I would definitely suggest read well, not like you're going to go home and read the building code. Yeah, I guess you could, but I would start reviewing it anyways.
Yeah, it's definitely a continuous process. I mean, I always say, even we had this discussion. I mean, even with a PhD, I think you only get 10 to 15% max of what you will actually need in the industry. So the university is just giving you really, really, when we say basics, it really is the very basics. And then you're going to have to learn a lot of stuff on your own once you start working anyways. We have another question here. So can you read it, or should I read it?
Yeah, no, I got it here.
Okay.
A decrease or increase in timber framers. Are you talking like because of the virus or just in general? So I think like the traditional timber framing, it's coming back. Like I know there's like if a community like Brockville can support one, and I know there's a few in Ottawa, that sort of thing. And so that whole like bringing back that aesthetic and that craftsmanship, it's coming back. So I think like you'll start seeing an upswing of more people doing it, for sure. Labor shortage, I think, is always an issue for Canada. But if timber framing is something you want to get into, like as like a labor or something like that, like I think it'd be a great career. And it's nice hands-on work. You're working with wood. I mean, in another life, that's probably what I would have done as well. But I think all of Canada is in trouble with labor shortage, and especially like the small towns that don't really attract a lot of people. I don't know why. Like Brockville's great, but yeah. Does that answer your question? Well, if there's something else you want me to talk about, then I can unmute you too. Here, I got that power. Maybe not.
Or maybe she muted herself. That's why.
Oh, okay. No, the construction sites are still going. They're declared an essential service, although that might be changing today, I think. But the construction industry is huge. So if you were to stop construction, you're really stopping the economy. So like I'm still in my office. Yeah. Oh, did Quebec close? Yeah. Like I think it'll be coming for sure. It's probably a smart measure. As an engineer, like I can work from home. I can work from my office. I work in a small office, so it's we're not really in close contact with each other. But it is important that we do our part. Like I went to a site meeting today, for example, and maintain that 6 feet distance and everything. So, but yeah, the announcement's probably going on right now, so we'll have to wait and see when the construction sites will be closed. Anything else? I think we're just a little bit over time. I like to keep things about an hour. I'm more than happy to stick around if there's some more questions, but I'm going to stop the official presentation. And thanks so much for joining me. It's great that you could come along. And like I said, if there's anything you need or some questions you have, then let me know. Thanks, everybody.
Yeah, thank you so much, Andrew. Thank you so much for taking the time to do this, and of course, thank you guys for joining us today, as well as always. I think this is going to be the last time I communicate with you, so I would like also to thank you for a great semester. You probably didn't end it the way you anticipated, but you have to go on with your regular life from now on, and with a lot of things that are not anticipated, and we just adapt with whatever we're given. So again, thank you again so much, Andrew, and thank you guys for joining us. And we'll be posting the presentation. Hopefully, maybe. I mean, I don't know how long it will take to upload and stuff, but hopefully by tonight, if not by tomorrow, definitely it will be up on See You Learn.